A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's talk will be in continuation to our previous talk under the module 8, where we will discuss the quality control and assurance related aspects, and then we will focus some of the important aspects related to the granular and earthwork courses. So at the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. In the previous lecture, where we discussed about the total quality management, we discussed about key steps which are to be there. So the different key steps which were key factors or steps which were discussed included the selection of the class of quality assurance depending upon the type of the project, then the information regarding the personnel, specifically the manpower involved, the quality assurance plan, very important. We discussed about the different aspects related to quality assurance plan, then the quality requirements for different kind of works, products, finished products or specialized items that needs to be prepared, laboratory setup so as to ensure these qualities of these products, works there in the lab as well as in situ. Then we discussed about the important aspect related to calibration of inspection, measuring and testing equipments, which is very important, which therefore is to be followed by inspection and testing. This information, all this information needs to be properly documented and communicated well. The information needs to be circulated well in as quick as possible. Thereafter, the statistical analysis has to be done on the different results which has been obtained to arrive to a decision, specifically in terms of acceptance, non-conformance, rectification, and required a third party quality audit may be also done for a particular project, and we need to ensure for the safety, health and environment during any road construction project. So these were some of the things which were discussed. We continue our discussion specifically, and as we discussed various terms, so again just mentioning certain things in a brief. The quality of a pavement course or layer can be defined by its ability to meet and preferably exceed. So whatever minimum requirements are there, the target should not only just to reach to the minimum targets, is to definitely exceed those minimum targets so as to meet the expectations of the customer or the owner specifically. So in practical terms, this translates, and during this course of time it has to be ensured that we are looking into the key attributes in terms of the constructability. The layer should be feasible to build with available resources, methods and within stipulated time. So this needs to be taken care. Second, conformance to specifications. Whatever works, products which are fixed under the particular contract agreement, it must adhere to the prescribed standards and technical requirements which are there in our standards as well as will be mentioned in the contract document. Performance assurance, the layer, whatever the works which has to be done, they should meet both structural and functional requirements, ensuring durability and serviceability of the road project. So during our today's discussion, we will be looking into different codal specifications. Some of them are presented here. Many more will be discussed during this particular course of talk. So this is SP11 MORTS 2013 specifications for road and bridge works, SP112, SP11 already amalgamated with 1112 manual for quality control in roads and bridge works. We will look some of the standard definitions which have been given by the ASTM. So the two important aspects, one is quality control, second is quality assurance. So quality control refers to that test which are required to control a product. What a product or a work which we are trying to produce, so the quality of that needs to be controlled. So for that, whatever exercises are done, specifically done by the concessionaire or contractor, are the quality control exercises. Then quality assurance, as we mentioned in the previous lecture also, takes care of the quality control also, acceptance part also to a certain extent. So refers to those tests necessary to make a decision on acceptance of a project, work or a product, because finally what product has been produced, that needs to be again ensured for acceptance, and helps to ensure that the product being evaluated is indeed what the owner specified. So whatever work which has been produced is as per the specifications which has been given in the beginning. So it is a three-pillar system can be considered for it. One is the quality control for getting finally achieved, is the where the responsibility mainly lies with the contractor or the concessionaire. Independent assurance can be done by any agency, specifically which doesn't involve the owner and the contractor. So any independent agency can be there. As we mentioned, a third party quality audit was there, so any independent agency can be involved. And finally, on the basis of this, you have to make a decision on the acceptance of it, so that will lie with the owner of that particular one. Now, while doing this investigations, specifically with road related materials or road related works, a variability is expected to exist. So is an inherent aspect of road construction activities, just as in case of any other manufacturer also, because some amount of variability is expected in the product, specifically in road construction projects, which are big projects involving a lot of different materials, lot of different machineries. So a variability is expected to be there. So the test results of a material or a mix which is produced largely depend upon the variability of their individual components. So you may have a variability, say a mix is produced, so in mix the aggregates are there, the gradations are there, different sources of aggregates are there, so different contents of it are, so individual components variability can lead to the variability of the final product. The equipment used, the production equipments, the compaction equipments, and even the equipments used for measurement also under different conditions. So these may introduce some variability into your test results. Projects will with well controlled processes. That's why it is very important we do all exercises so as to have our the process for reaching to that particular work or product is well controlled one, so that we can produce materials with low variability. We will try to take all measures so that less variability is there. While poor control, if the control is not good, then see the control. If you are producing a mix from a wet mix plant, there it needs to be controlled. When it is laid by pavers, there it has to be controlled. When it is compacted, there it is to be controlled, and under what testings you are evaluating it, that needs to be uniform. So if that control is good enough, you are able to reduce the variability of it. In addition, significant variation may arise from the sampling procedures, how you are sampling that particular one. So the sampling also has to be done in a proper manner which can be accepted by all. It can be accepted by the owner also, it can be accepted by, it needs to be accepted by the contractor also. So the sampling procedures, testing practices, often as I mentioned that even the density gauges are there. Certain density gauges show less variability in comparison to other density gauges. So your testing procedures also give some inherent variability to your results. Therefore, we need statistical analysis becomes an essential tool for making informed acceptance decisions, because that we need to inform, and we need that needs to be accepted by all the agencies which are involved. So most of the characteristics or parameters which are considered in road construction, for example, it may be properties what we look into is specifically by the materials or the works which we do, maybe in terms of aggregate gradation, in terms of the density of the layer. If it is a bituminous mix, it may be in terms of the air voids in the bituminous mix, binder content, it may be in terms of the stability of those mixes. So these are some of the parameters which are worked out, but then whenever these parameters are looked into it, so if we plot the results in terms of the frequency of those results, usually we get histograms in this particular bell shaped pattern. So, we will have more values near the mean one compared to we will have lesser frequencies to the edges one. So, it is most of the times we get a bell shaped pattern specifically for the products or materials which we use in road construction. So, a curve drawn through the upper points of such frequency diagrams resembles the normal distribution curve. So, this follows a pattern, specifically the pattern of a normal distribution curve. Recognizing this particular aspect, it is good to follow a normal distribution because it enables the use of a relatively, because we need to work out the property characteristics of a big section from a smaller number of samples. So, that is why if we are well aware what kind of distribution can be there, what kind of variability can be there of that particular parameter, it will help us to work out with relatively small number of tests to reliably predict the characteristics of the entire population or lot. Here I mentioned the word lot. Specifically in road construction, we refer lots, we will discuss lots and sublots in upcoming slides also. It is normally a one day work which may be there. So, in one day work a length of section may be constructed. So, that we can consider as one lot. So, in that particular one lot, we may divide that particular job into smaller sections from where we can pick up the samples for our testings or we can do the test. So, that will form our sublots. So, with a smaller number we are able to reliably in a confident manner we are able to predict the characteristics of the entire lot. So, that is what is required through this statistical analysis. Now, certain parameters which are important for the statistical analysis of the results of the different tests which we normally refer in specifically in road construction works. One is the variance, which measures how far set of numbers is spread out. This is for the variance. Then we have the commonly used parameter standard deviation, which is a measure to quantify the amount of variation or dispersion of a set of values. So, this is what we have for a standard deviation. Then we have the coefficient of variation. It is the ratio of standard deviation to the average of measured test results. This is again many a times referred this particular one. Then we have one more parameter which is the standard error of the mean, specifically the sample mean. When we are looking for a small number of sample means, this sample mean may be a bit differ from the your true population mean. So, we have the standard error of means. So, these are certain parameters which are required in the statistical analysis of the results which we attempt for the road construction works. Now, if we have a normal distribution curve, two normal distribution curves are drawn here using the mean and standard deviation for say example of 5 to 10 test results which have been done. So, 5 to 10 samples have been tested for a particular characteristics and we plot this particular normal distribution curve. So, in that case you can see that this particular one is having a small dispersion of the data. So, this is your mean. So, you can see the dispersion of the data is quite less compared to the other one which is for the B. So, however, the mean in both the cases is same, but the dispersion, so I can say in one particular set, so where the control is not good, the dispersion of the results or the variability will be high compared to a one particular project where the variability is less, and I will always expect to, and I will always look for a project which have a good quality control, so that my variability of my characteristic property is less. So, as shown in figure, both curves A and B share the same mean, but curve B has a larger standard deviation indicating greater variability or scatter. So, that is not preferred. So, the bell shaped normal distribution curve is symmetric about its vertical axis with midpoint representing the mean. Now, if we have the probability density function, then whatever the total area which will be under this particular one will be equal to 1. So, this is the standard characteristics of a normal distribution curve, normal distribution probability density curve. Now, further if you look into it, any value x can lie to the left, any value can be there. So, we have seen this is the normal distribution, we can see how much the value is varying with respect to the mean on the lower side and how much it can vary with respect to the mean on the greater side. So, lower and so I can say it right hand side and left hand side. So, any value x can lie to the left negative or right positive of the mean, and its distance from the mean measured with respect to the standard deviation. So, it can be measured with respect to the standard deviation, and that particular parameter is important specifically, and we call it as standard normal deviate. Z is determined, which gives you the idea about the variation with from the mean with respect to the standard deviation. So, this is the Z standard normal deviate, which is calculated in this particular manner. It gives the idea about how much variation is there from the mean with respect to the standard deviation. Now, these standard deviates and then are specifically used for the standard probability density curves, specifically for probability distributions for normal distribution curve, and from there we can work out the area under these curves. So, the area in the tail beyond a value indicates the probability that the variable will not exceed for the positive side or fall below the negative sides. So, for this, once you have these standard normal deviates, we will make use of the standard probability tables for normal distribution curves, and here you can see from this we can work out, say for a value of z of this one, what is the area specifically in this one. So, that gives us the probability density, specifically how much probability is there that the results is lying in this range, and how much probability is there that it is exceeding this particular one. So, this helps us to get an idea about where our results will be is expected to lie. So, this normal standard deviate, which is your Z statistic, defined as the deviation from the mean with respect to standard deviation, indicates how far a value deviates from the mean in terms of standard deviation. Now, then we use these standard statistical tables specifically for corresponding area. So, here you can see this is the probability distribution curve, and it can be for any characteristics. If I mention here, it may be for density, it may be for say air void content, for any. So, here if the Z is having a value of 1, so it shows that whatever the area which is under this particular curve less than this one is equals to around 0.8413, and whatever which is exceeding or towards the tail on the right hand side will be 1 minus 0.1587. So, for example, it says at Z is equals to 1, the cumulative area is 0.813 up to this particular point from here to here, meaning that 84.13% probability that the variable will not exceed this value. So, that whatever if we have this Z statistics or standard normal deviate value as 1, that gives an idea that will not have results which are at least 84.13 results will be there, which will not be exceeding this value of 1. Probability that the variable will not exceed this value, and 15.87 that this may exceed. So, we are getting an idea. And similarly, if it is there on the negative side, it can say that depending upon it may the variation here is on the right hand side. If the variation is on the negative side, then similarly we can say that there is a 84.13 probability that the variable will not fall below this value, and whatever in this particular tail will be there. So, that will be again 15.87. So, now if I need to look into what exactly if these two limits are to be ensured, then I am trying to look with the probability my results are in this particular range. So, it says the probability of a value lying between Z minus 1 and Z plus 1 is therefore 1 minus how much it is exceeding on both the ends. So, then it is 68.26 are there. So, if I have a value, a characteristic quantity or a property which is having a z statistic value of 1, so there in that particular case I can ensure that around 68.26% will be lying in this variation with respect to the from the mean with respect to the standard deviation. So, and 68.26% will be the results are expected to lie in this range. So, IRC-SP 112 in a similar fashion explains that if we have a value of the standard normal deviate of a value of +1, then it says 84% probability is there that x will not exceed mean plus your standard deviation, and 16%, 15.87 rounded off, it has mentioned 16% probability that it can go as low as 16%, and therefore, a 68% is there that it is within this particular range. So, this on the basis of a standard normal deviate of a +1. Similarly, if I have a -1, so in that particular case z +1 -1, I will have allowance of 68%. Similarly, if this z value is ±1.64 in terms, then I can say that 90% probability that it will lie within this particular range. So, depending upon this variation, I can work it out how much of my data is specifically lying between this particular. So, this decides that how much confidence is there that 90% in this particular case 90% of these results are, and if as a single limit, if this is a single limit, if it works out, then it says, and I may have a requirement where it can be a lower limit also, upper limit also. Lower limit, say density, I specifically mention that the density should not be lesser than this one. So, this is called as a lower limit. For a certain other characteristics, I can mention that the moisture content, say if that should be not be more than this particular percent, or any other say percentages of say voids in mineral aggregates or air void content should not be more than 6%. So, that is on the upper end. So, similarly, this is a standard normal deviate for 1.96. It says in that particular case you get a 95% probability that it is in this particular range. So, similarly, for a value of standard normal deviate of +2 and +3 as taken from the standard probability tables of normal distribution. So, once we have this particular information, thereafter as I mentioned, we need to pick up the sections or the quantum of work for making this exercise. So, for acceptance of a production of a work under a road construction, it is quite often that we need to divide the work into lots and sublots, as I mentioned. So, for that one, a lot is a quantity of material produced from a single source specifically. So, that means a single source means the variability, it is one day when we are running a wet mix plant, one day when we are running a hot mix plant. So, we are expecting that there is a uniformity in that particular process from the in that one day work. So, under uniform conditions, so for example, a section of a pavement layer constructed on the same day using the same materials. But yes, there may be chances that in due course within one day's work also, if some variability exists, a major variability exists which is known to you, then we can further consider it as a 2 lots. Otherwise, normally in practice one day's work is considered as a 1 lot. So, a sublot is a division of lot specifically used for sampling purposes. So, how I can reduce it to sublots so that I'll do some samplings there. So, similarly depending upon for different kind of characteristics, we may have to work out around 6 to 10 number of samples, and that will again depend upon how much frequency is stated in our codal specifications or contract agreement for a specific characteristics. So, certain characteristics require more number of tests compared to the other. So, typically say for an example 6 to 10 sublots are considered within a lot, and samples from each lot are tested for properties, and the properties can be density, it can be binder content, it can be your aggregate gradation. So, the material can be picked up and tested, and within these sublots also it is important, see it is mentioned, that is why we do not want to put all our sample testing at one place. So, it has to be distributed along the entire lot work, and within that particular sublots also the locations has to be picked up in a randomly manner. This is another concern, that it should not be there at say near to the center line and the middle of the lane or edges. So, in a random manner, using the table of random numbers, we can decide this particular one, the XY coordinates for our different sample locations. And then the second specific requirement, as I mentioned, there may be certain characteristics where you may be requiring only one limit. So, for density part, I am just trying to look that the density should be more than say if it is for subgrade construction or granular courses construction, my requirement may be say 97% of the maximum dry density or 98% of the laboratory derived maximum dry density. So, these specification limits, these are allowable values set around a target for quality. So, characteristics. So, we set certain targets specifically. A limit may be a single specification, either single specification may be as a lower limit or as an upper limit also. That upper limit, if an aggregate, say I pick up a particular sieve where a material is having certain percentage passing, or say any particular characteristics which may be in terms of the shape. So, shape, if I mention that the shape of the aggregate should have a combined flakiness and elongation index value of 35%. So, it should not go beyond 35%. So, this is upper specification limit, and there may be certain requirement. Similarly, it is for impact also, it may be 24%, 27%, and there are certain requirements where it should not fall below certain limit, which may be in terms of binder content, which may be in terms of your density also. So, a limit may be a single specification limit, either an upper specification limit or a lower specification limit. A pair, and there may be certain characteristics which have upper specification limit and lower specification limit, as we have in case of air void content. Say air void content, when we have bituminous mixes, the air void content may be in the range of 3 to 5%. So, there is a lower specification limit also, there is an upper specification limit also. So, I need to ensure that it lies within both the upper and lower specification limits. So, this is a quality measure. Now, on the basis of that, we need to work out what is the quality of the work. So, a quality measure evaluates a material, layer or a component against a specific quality. So, we can measure a quality of a particular work in terms of different attributes or different characteristics. It may be meeting one characteristics, but may not be meeting the other characteristics. So, you should be well aware one particular work is to be ensured in terms of what characteristics. And finally, we need to go for the statistical acceptance. So, the common measures includes percent defective and percent within limits. So, how much quantum of work is there which is outside the limits, and how much quantum of work or how much of your results are within the acceptable limits. So, we have the percentage defective and the percent within limits. These are the two terms which are very commonly used. So, these measures are quite preferred at the efficiently capture both average level as well as the variability of the characteristics. Here I can show you. So, the first one is percentage within limit. So, now you can see in this particular distribution of the results, normal distribution of the results, you can see if I put up the lower limit and the upper limit here. So, percentage within limit is the percentage of the lot falling above the lower specification limit. So, what I require, if there is a requirement of 3 to 5% of air void content, then I will put up this. Even this may be for any other volumetric parameter. In case of bituminous mixes, like we have the voids filled with the bitumen, where we say that the voids filled with the bitumen should be in the range of 65 to 75%. So, there we have both the lower specification limit and the upper specification limit. So, whatever percentage which is falling outside of it is the percentage defective, and whatever results lying in this particular one will be your percent within limits. So, percent within limits is the percentage of the lot falling above above the lower specification limit and beneath the upper specification limit. So, that is the between the lower specification limit and upper specification limit. It is similar to determining as we determined the area under the normal probability density curve, where under the normal curve bounded by lower. So, we can fix up the lower and the upper specification limits and work out what are the percentage area which is falling outside of that our specification limits. So, percentage within limits is estimated using sample mean and the population sample standard deviation. This is what we work out in a similar fashion as we explained in the previous slides. So, percentage within limit, what it says, if it is a single limit, it can be 100 minus percentage defective, and this defective can be on the upper side also and a lower side also. So, this can be percentage defective if it is a single limit. So, percentage defective on lower side or percentage defective. So, whatever going beyond it or whatever going lesser than this particular one. So, that is the case when single limit criteria is there, and percent within limit, if both you have the criteria for the upper specification limit and lower specification limit. So, then you have this one. Now, on the basis of this particular one, we get the percentage defective. So, now what is the percentage which is lying outside indicates the percentage of lot falling outside the specification limits. So, you can fix it that I require only 5% of my results to fall out of the my specification limits. Only 5% results are allowed to fall outside of it. So, we need to ensure for this particular one in our specifications that only 5% of results can be, and depending upon if it is say the requirement, if it is only one limit, we can mention that only 5% of the results can be lower than this particular value, or 5% results can be more than this particular value. Now, percent within limits indicates the percentages of the lot conforming to the specification limits, and many a times on the basis of this percent within limits, we introduce a pay factor also, that if the percentage within limits is ensured well, on the basis of that percent within limits, we can release the payment for a particular work. So, this is also practiced in different countries, specifically on the basis of how good the quality control is. On the basis of it, we can release the payment, or we can even give some bonus if we are finding that the quality control is good enough. So, in respect of the following materials works, a statistical analysis procedure is adopted for the quality control, specifically what it says for the works related to the earthwork. So, now as I mentioned, it depends whether how many number of samples has to be tested. So, as per the requirement of SP 112, it says for earthwork, for embankment, what quality characteristics which is usually ensured is the compaction. So, we ensure for compaction, and what is a typical lot size? So, it says around 3000 square meter, but limited to a single day's production work. So, if the single day's production work is less than that, we will go consider that as a lot, not we will accumulate 2 days work to form 3000 square meter. And then how many sublots can be there, so that we at least get 10 number of samples to ensure the compaction quality. Similarly, it says for subgrade, we need to go for a smaller area, that is 2000 square meter, but always if in one day we are not able to produce whatever work which is lesser than 2000, that lesser one will be considered. Again, sample numbers are to be done. So, we do the compaction test and ensure for it. And how the information is recorded, this is very important. You can see this is a format which has been taken from SP 112, which mentions that what is the source and location of the lab, then material sources and records are the bore area from where the sample has been taken, optimum moisture content, maximum dry density which is to be ensured, date on which this particular test is there, chainage, at what chainage this test has been conducted out, on which layer we are doing this particular one, what is the during this sand replacement procedure specifically, we need to know the standard sand. So, what is the bulk density of the sand which has been used. So, so that we are able to look into the variability of it. So, as I mentioned, the testing procedures variability can also introduce variability in your test. Weight of sand in cone. So, if the setup is bit changed, what you have used in one particular location, if it has changed with respect to the other one, and then we record the individual observations finally, and it has been who has prepared this particular one, who has been there ensured for this one. So, all this is how the information has to be recorded in a proper manner. Now, similarly, these quality characteristics are to be ensured for granular courses also, and where it says if I am using a material say for granular sub-base course, then the compaction, again what specific characteristics which is ensured is field density to give the acceptance, rejection or any rework which is allowed, and here it mentioned again 2000 square meter is good enough, and we can go for 5 number of samples in that case. When it is for wet mix macadam, typically used for base courses, again this particular one is in terms of compaction density, and we usually go for a 2000 square meter of area limited to a single day work with 6 number of samples. So, these, as I mentioned earlier also, these are tentative, these are some guidelines in terms of how many number of samples you require. Depending upon seeing the actual variability which is happening, if you are finding that certain section is having more variability, you can go for more number of samples in that particular case. Now, once that quality characteristics is there, as the compaction density has been there in the granular courses and the subgrade one, thereafter we try to ensure the acceptance. The acceptance is in this particular manner, as this is for 95% confidence level when we are looking specifically for single limits, because here we are trying to ensure for the density part. So, if the mean, so this acceptance criteria has been if the mean of the value of all test results of the sample is more than the specified value, oblique less than the specified value. This is the two cases, specifically there can be an upper specification limit and a lower specification limit. Specifically, if we are checking for the compaction density, it will be the lower specification limits only. Now, so here it says in that particular case the mean should not be less than the specified plus this particular one. But if there is some upper specification limit, so then it will be, it should not be more than the specified minus this particular one standard deviation. So, here it says this is specifically when do we use more than and positive if lower specification. If I have a requirement that my density should be, which is for my compaction density, so my mean density should be more than the specified one. Specified maybe say 97% of your MDD plus your this into the standard deviation. If there is a certain requirement, as I mentioned, it can be in terms of the air void content or in terms of any aggregate particular gradation characteristics, then it says that this should be less than the specified value minus this particular one into standard deviation. So, the number of samples, as already specified, what number of samples you have to pick for it. Now, once you have this particular one, you are able to work it out. Okay, the number of the lot you have decided, the sublots you have decided, you have done the testing, you have verified whether it is meeting the requirement. As I mentioned that if it falls certain sections, if it falls, what actions have to be taken up if it is not meeting the requirements. So, one is if there is a possibility, already your contract document will mention this particular one, that certain elements may be there or works may be there which can be reworked. Specifically, as I mentioned, if some aggregate gradation is not working it out, then I can rework that material with some additional material to reach to the desired gradation. If density is not working out for a subgrade course, I may open it up, I may again add water to it, and I may recompact it to meet the specified, but this should be specified there in the contract. So, for example, an aggregate stockpile filling gradation requirement for a particular work may be mixed with aggregates of suitable sizes, so that now the blended aggregates meets the requirement. So, this can be one way of doing the acceptance if something is falling out of it. Second is accepted with reduced pay factor. As I mentioned, if the when the percent defective is more than certain percentage, then if the clause permit, there can be, if a particular job is there which can be accepted, but up to a certain limit only, and with a reduced pay factor. That means whatever the earlier price which has been fixed for it, or the cost which has been fixed for it, will be reduced specifically. So all these have to be already there, should be mentioned in your contract document, then only these can be exercised. Third possible option can be regraded for alternate use. Whatever material you have, you are finding it unsuitable for a particular course. If you are having a granular course, a gradation which is there, you are not finding it good enough. If you are finding a particular soil not good enough for one work, you can explore it for some other work. If it is not suitable for, say, subgrade construction, you can explore it at certain location where some embankment construction is there, whether at that particular location it can be used. So it can be explored in that manner. And if there are certain jobs which cannot be considered under the previous three categories, then it needs to be rejected, and it is to be reworked, or replacement has to be there. The work has to be has to be removed and reconstructed. So if none of the above options normally works, this has to go into this particular manner. Now, as I mentioned, applicability of a particular option to a particular material work, other than one is a typical exercise where we especially work, which is a common exercise, maybe not possible with all different courses, but usually for subgrade granular courses, that is the one common exercise worked out. But other than option 1 and 4 shall be specifically, when we are looking into 4 is a complete rejection, you are not accepting that particular course, it has to be removed. First is you are doing a small amount of exercise to bring it to the required specification. But these two, what in between, that it can be used to some other use or some reduced pay factor is to be there, should be in accordance with the conditions of contract specifically mentioned therein. So that should be specifically mentioned already. So this is, we discuss some of the aspects related to the statistical analysis tools which we employ to judge the variability of the materials used in road construction, and we discuss some of the characteristics, properties which we need to look for, specifically earthwork and granular courses. In the next lecture, we will look again for the characteristics of bituminous mixes to ensure their quality. Thank you so much.